Okay, so now that we've found of these blue cubes, 544 approximately fit inside a cubic meter.
So
Let's find the volume of our rhombic dodecahedron. So how are we going to do that now?
So, well, we would need to find the relation of the blue side that we had to the yellow side.
oh, we can just measure. We can just measure across.
Ooh, you want to keep it right there.
We can measure
Oh, in
across.
fact, you know what? I'm going to zoom in exactly right here. Okay. Tell me what you want to measure.
We can measure across here because that's what the blue side was.
Okay.
The blue sides go across the faces.
All right. So then, once we've determined that measurement, what are we going to do to find the volume of our rhombic dodecahedron?
So we're gonna cube this number and then multiply by 2.
Okay. So what I want you to do is each one of you let's say 3 measurements. You can even these should all be the same because we 3D printed them from the exact same model. But let's take 3 measurements across that middle part, and we'll just take the average of the 6 measurements total. Okay.
So this one looks to be about 25.
Okay. So now find another one and put it in the same place and then measure it, since we're way zoomed in on the screen.
Oh no, that wasn't. Okay, this one looks to be about 24.
Okay, 25 plus 24 plus.
Let's do this one.
Oh, a little over.
Yeah, good.
And this one looks like it's about 24 as well.
Okay, plus 24. All right, now you do 3 measurements.
All right. Let's see.
Okay, you're on the screen.
$24 for this one.
But those are you measured those. So find a new one.
Alright. This. Alright, 24. And then
Alright, so this is the last one.
that one looks to be 24.
Alright. Alright, so we'll divide that by 6. And so we have just a hair over 24,
Yeah.
is what we think. So times itself times 24, I think it was 0.166666. Alright. That's how many cubic millimeters.
We need to multiply by 2.
And now we need to multiply by 2. So that's our volume of this
In cubic millimeters.
in cubic millimeters. Now, we found 544 of our zone shapes fit into a cubic meter, of our zone cube fit into a cubic meter. So how many of the dodecahedron fit in?
Or the
Divided
rhombic
by 2, so
dodecahedron.
it's 272.
272. Do you agree with that? All right, 272. So let's see.
Any of these fit into a cubic meter.
Well, there's a couple different ways we could do it. We could do the same calculation, or do you remember how long the side length was here?
I think it was the side length of the cube.
Yeah.
I think it was like 122 millimeters.
Okay.
And this one was about 24.
Right.
So I mean that's roughly
That's
122.
it's roughly like 1/5.
so that's about 5.08.
Okay.
So
So what do I have to do
we have
here?
to cube that. So 100,
So
125.
5.0833. Oops. 5.083333. So about 131.
Can fit into our big rhombic dodecahedron.
Okay.
And of that, what did we say, 277? So 277 of them can fit into a cubic meter.
Where did the 277 come from?
Was it 277? So we said for the cube that it was 544 that could fit.
That's right.
So, and then we had to divide by 2 because the rhombic dodecahedron was twice as big.
Okay.
So, it's 272.
272. Is that right?
Yes.
Okay. So what do we do with our 131 now?
So we we're gonna get it.
So then we have to multiply it by 272.
So there we go.
35,728.
So let's call it close to 36,000 of these to fit inside a cubic meter.
I guess that would make sense.
Divided by 272. Oops, what did I do? And about 131 of these to fit inside here. Would you have believed that?
No.
No.
Well, there's a lot of space. That's
Yeah.
130.
I mean, I don't know if it's physically possible to do, but at least the volume, just looking at the from a volume point of view, it's possible, but like physically, I don't know if they do go together, but I don't know if they go together in that shape.
That's true. They might not go together in that shape, but it's hard.
Fractions.
It's hard to believe. Let me zoom out. That 131 of these is what it takes, but that's what the math says, right? I mean,
Yeah.
it's basically 1/5 as long, so that would tell you 125, and it was a little more than 1/5,
Yeah,
a little higher. So,
it's pretty neat.
anyway, so we found the volume. We found the volume of this was 1/131st of this, and we also calculated exactly, but I don't remember what the number was. But so the big lesson here is when you're trying to find the volume of a specific object, what do you need?
Measure.
Measure.
You need to measure it. That's one, and then once you make the measurements, what do you need?
You need to know the volume formula.
Yeah, you need to know some sort of formula for the volume.
Yeah.
If you don't know the formula for the volume, then there are other ways to find the volume.
Yeah.
If you don't know the
Figure out the
formula.
formula.
Well, we don't know the formula for this, but we know that it's composed of 2 cubes.
No, but you do know the formula.
Oh, I guess that
for
is the
this.
formula.
It tells you the formula. All right. Good work, guys.